Hello, welcome. Let us continue the lesson. This lesson will cover the assumptions in hypothesis testing for a single sample mean. We will be covering the null and the alternative hypothesis. This part 2 discuss basics of distribution theory that deals with the population and sample. The learning objectives: you will be able to explain the terms population and sample. To understand that the important characteristics of your sample is random. To understand the terms parameter and statistic. To understand the binomial distribution and normal distribution. To explain the meaning of the sampling distribution of mean. Statistical testing hypothesis will be covered. This involves making decisions on the characteristics of a population using the sample values. We need to specify the relevant methods and define various terms connected with the population and sample. What is a population? A collection of units on whom we are interested in measuring some characteristics or classifying them into categories. Example: a collection of laborers in a particular region, a collection of plants grown in a farm, a set of patients with some specific disease, an enclosure of plots, that is piece of land containing mineral deposits, etc. What is a sample? A part or portion of a population. Members of sample are selected according to a rule of probability. If each unit receives the same probability of being selected, we say it is a random sampling. There are methods for selecting a random sample. We assume here that the selected sample would be a representative of the population. We expect that the sample reflects the characteristics of the population, though it may not be possible. This is a population, a collection of units. Some elements are coming in to occupy the sample. So, this is the picture of population and sample. Please note that sample is not consisting of any other material, but the elements of population are sitting in sample. Instead of dealing with the individual units, we consider the values of a variable measured on all the units such as height, salary, etc. Or we may classify members according to a characteristic such as sex or a region they belong to or their opinion favoring a party, etc. We consider only a computed value of the characteristics for each unit. For example, mean height, standard deviation of weight, correlation between two measures of each unit, height and weight, marks on two subjects, and so on. Proportion of TB patients in a region. We will be using two terms, parameter and statistics, in our course. What is a parameter? A computed value using population units is called parameter, such as mean height, that will be explained later. Similar computed values using sampling units is called statistic. Conventionally, Greek letters mu, sigma, etc. are used to indicate the parameters. Example: for mean we use mu, for standard deviation sigma, for proportion phi, so on. Roman letters are used for sample statistics: p for proportion, m for mean, sometimes x bar, s for standard deviation. A population of values can be described using the concept of distribution. A distribution can be a list of probabilities for its values or a mathematical function. So, I recall here you can make a list of values and the corresponding probabilities, that is easier way, but mathematics provides a beautiful functions and concise definitions. Three important distributions are binomial, normal, student T. A binomial distribution is described by the following: let each unit be assigned a fixed value according to a category or classification level, etc. Examples: sex is a factor in which a male is assigned a value 1 and a female is assigned a value 2. Opinion: an unit gets 0 or 1 or 2 if the opinions have 3 categories. Consider the case of only 2 categories taking 0 or 1. Let P be the probability for an unit to have the value 1. The sum of values of all the units having 0 or 1 is equal to the number of people having the value 1. We shall denote this sum by x, which is a random number. A distribution of x is a list of probability values for all the possible values of x. Statistically, here we have binomial probability distribution. Graphically, I can represent like this. You can see that in the x axis there are values 0, 1, 2, 3, 4 and so on. For each value, a vertical bar is erected. It shows it has different heights according to the different probability values. Now, we shall describe normal distribution. Consider a measured variable such as height, which is a random variable. The height has normal distribution. It is obvious that the height is affected by numerous causes. The contribution of each cause may be small, but may add a positive or negative effect to height. Some of these causes influence the value of height. When a variable is affected by numerous causes, then we have a normal distribution. This is a characteristic of normally distributed variable. A normally distributed variable will have a curve like this. Again, the x axis represents the value taken by x. Note that the left end is -3, right end +3. I am plotting a normal distribution with the 2 parameters 0 and 1. I will explain later. It is centered at 0 and it have a standard deviation 1. For a large number of cases, a binomial variable has a distribution that resembles a normal distribution like this. You can see as a bar diagram representing the normal binomial distribution, but the form is a bell shaped curve. An important result on the mean of a sample will be stated now. Suppose a population characteristics x has a normal distribution with some mean, say mu, and standard deviation sigma. Suppose we take a random sample of n values. The sample mean is computed as x bar and sample standard deviation as small s. Result 1: x bar has normal distribution with the mean mu and standard deviation equal to sigma divided by n. This implies that the distribution of sample mean is again normal with the same mean, but the dispersion is smaller than that of the population. We have plotted the normal distribution curve for population and sample. The red colored curve indicates the normal distribution of the population and the blue curve is for the sample means. This has a normal distribution with the same mean, but smaller dispersion. How small this dispersion becomes depends on the value of n. Result 2: when the population sigma is unknown, it can be estimated from sample standard deviation small s by the formula we are given here, you can read it, or in the calculation of s or in the calculation of sample standard deviation, instead of dividing by n, one must divide by square root of n minus 1. Moreover, the normal distribution appears in almost all the fields of research. How can be sure? This is ensured by two important axioms: law of large numbers, second one is central limit theorem. Both axioms are concerned with the means of random samples. These axioms say that as n becomes very large, the sample mean approaches a normal distribution with the same population mean, but with smaller standard deviation. We will summarize what we have learned in this part. We considered the concepts of population and a sample. The sample must be selected according to a random procedure. The sample must be a representative of the population. We considered two important probability distributions and saw how they appear in applied research areas. You are given basic concepts and fundamental ideas that are being used in psychological research by using statistics. We continue this lesson in the next video. Thank you.